Welcome back to Tiny Food Scientist, where small foods reveal big secrets. Today's question is, what amazing science are we discovering today? Stay until the end. You might be surprised. Don't forget to like, subscribe, and join our food science adventure. What if I told you the burning sensation from chili peppers isn't actually heat? No fire, no high temperature, no real damage. And yet, when you bite into a chili, your mouth feels like it's on fire, your eyes water, you start sweating. Your body reacts as if something is seriously wrong. So what's really happening? Why does something harmless create such an intense reaction? Today, we're diving deep into the science behind spicy food and uncovering how a tiny molecule can trick your brain into feeling pain. Let's start with the biggest misconception. Spicy food is not hot in the way fire or boiling water is hot. There's no actual increase in temperature happening inside your mouth. Instead, what you're experiencing is a chemical illusion. The key player behind this illusion is a compound found in chili peppers called capsaicin. Capsaicin is the reason some peppers feel mildly warm, while others feel explosively hot. But here's where things get interesting. It doesn't burn your tissue. It doesn't damage your tongue. What it does is trick your nervous system. The moment capsaicin touches your mouth, it begins interacting with specialized nerve endings. These nerves are responsible for detecting pain and temperature. And capsaicin sends them a very specific message. You're burning. Your brain receives that signal and reacts instantly, even though there's no real heat involved. To understand how this trick works, we need to zoom way in down to the molecular level. Inside your body, you have a protein called the TRPV1 receptor. Think of it as a sensor. Its job is to detect extreme heat, typically temperatures above 43 degrees Celsius. When you touch something dangerously hot, this receptor activates and sends a warning signal to your brain. It's your body's built-in safety system. But capsaicin has a unique ability. It can bind directly to this receptor and activate it without any actual heat. In other words, capsaicin hijacks your body's heat detection system. When it locks into the TRPV1 receptor, it forces the channel open. This allows ions to flow into the nerve cell, triggering an electrical signal. That signal travels to your brain, and your brain doesn't question it. It simply reacts. This is burning. Do something. This is why the sensation feels so real. Because from your brain's perspective, it is real. Now here's something almost everyone has experienced. You eat something spicy, your mouth is on fire, and you reach for water, but instead of helping, it somehow makes things worse. Why? The answer comes down to chemistry. Capsaicin is hydrophobic, meaning it doesn't dissolve in water. Instead, it behaves more like oil. So when you drink water, you're not removing the capsaicin, you're spreading it around your mouth. It's like trying to wash grease off your hands with just water. That's why the burning sensation lingers. But if you drink milk, something different happens. Milk contains fat and a protein called casein. Casein acts like a detergent. It binds to capsaicin molecules and helps pull them away from your receptors. This is why milk can actually reduce the burning sensation. So next time you're struggling with spicy food, water isn't your friend, chemistry is. Once the TRPV1 receptor is activated, your body shifts into response mode. Your brain believes you're overheating. So it activates several defense mechanisms. You start sweating to cool down your body. Your eyes produce tears to protect sensitive tissues. Your nose begins to run, helping flush out irritants. Your heart rate might even increase slightly. All of this is your body trying to deal with what it thinks is a heat emergency. But here's the fascinating part, none of it is necessary. There's no actual burn, no real damage. It's a full body reaction triggered by a single molecule sending the wrong signal. Now here's the paradox. If spicy food triggers pain, why do so many people love it? Why do people seek out hotter and hotter peppers? The answer lies in your brain's reward system. When your body detects pain, it releases chemicals called endorphins. Endorphins are natural painkillers. They help reduce discomfort, but they also create a feeling of pleasure or even euphoria. So after the initial burn, your body rewards you. You feel a kind of spicy high. This creates a unique experience, pain followed by pleasure. And for many people, that combination is incredibly addictive. It's similar to the thrill of a roller coaster. Your brain knows you're not in real danger, but your body reacts as if you are. And that contrast creates excitement. But here's the fascinating part. None of it is necessary. There's no actual burn, no real damage. It's a full-body reaction triggered by a single molecule sending the wrong signal. Not all chili peppers are created equal. The heat of a pepper is measured using the Scoville scale, which tells us how much capsaicin it contains. A bell pepper has zero heat. A jalapeno has a mild kick. But something like a ghost pepper or Carolina Reaper, those contain extremely high levels of capsaicin and can trigger an intense reaction. The more capsaicin, the more TRPV1 receptors are activated, and the stronger the illusion of heat. So the next time you eat something spicy and feel that intense burning sensation, remember there's no fire, no real heat, just a tiny molecule tricking your brain. If you enjoyed this deep dive into science, don't forget to like, subscribe, and share. And tell me in the comments what's the spiciest food you've ever tried. See you in the next video. So the next time your mouth feels like it's burning from chili peppers, remember this: there's no real fire, no actual heat, just a tiny molecule, tricking your brain into feeling pain and somehow turning it into something we actually enjoy. But here's the real question. What's the spiciest food you've ever tried? Was it worth it or total regret? Drop your answer in the comments. I'm reading all of them. If you enjoyed this kind of mind-blowing science, hit like, subscribe, and turn on notifications. Because the next video will change the way you see everyday things again. Your brain can be fooled, and this was just the beginning.